In order to clean the boat and sand it all, I had to get it flipped up over on its head. So I made this rack with some sawhorses that I had, some 2x6s, and picked up car dollies in order to be able to put the whole system together, which allows you to move it around the shop a lot easier, get it out of the way, do whatever you need to do with it without having to pick it up and manually do it. It also allowed me to keep a lot of the spray off the ground. Just really worked out pretty good. So this is the bottom of the boat now that I got done stripping all of the paint off. It also had a layer of like a 1/16 of an inch rubber coating on the bottom of it, which was an absolute train wreck to try and get off. So after countless hours and countless days of stripping this all off, I was finally left with a bare metal. You can see that in the picture. Best thing I found to get the material off the bottom of this without damaging the hull itself was these stripper discs. Get them for an angle grinder. Did a great job getting the paint off and the rubber coating off the bottom of it without actually getting into the aluminum. You can see in the pictures that we were down to bare aluminum, at which point in time I went through, cleaned the whole thing with alcohol, and hit it with 2 coats of self-etching primer. I found the self-etching primer does a really good job of bonding to aluminum. Aluminum's one of those things that are hard to get the stuff to stick to. After the 2 coats of self-etching primer, the entire boat got 7 coats of Rust-Oleum satin finish, coastal gray. I went with the satin finish because I wanted something that would be easy to touch up, but I also didn't want flat. Flat paint tends to attract dirt a lot more. So that's why we went with the satin. I think it'll be a little bit easier to touch up if we get scuffs and stuff along the way. You can see in those pictures that there was a lot of work that took place with it. Before I went through and did all the painting, you'll notice there's a bunch of rivets that run longitudinally along this edge. That's because I went through and put all the angle aluminum inside of the boat prior to doing the painting operation. That way all the rivets would get painted and I wouldn't have to go touch them up again. You can see in this video the aluminum angle, and I'll get into it more here in the next bit. On the front of the boat where the winch and the tongue post connect to the boat, I went through and put on another additional piece of aluminum on the front of it, which will give me more support for that post to push up against. They were buck riveted in. I did end up getting buck rivets and a buck rivet tool for this, and an air hammer. You don't have to spend a lot of money on an air hammer. They're pretty cheap through our Harbor Freight. And then that's the buck rivet tool right there. It's got a coned head on it to make the buck rivet round. And the only other thing you need is a bucking bar. I just used a heavy steel plate as my bucking bar. It's probably 1 inch thick by 3 inches. Did a good job. You can also use like a flat hammer. You just need something heavy to counter the impact of the hammer drill, or the hammer. So that's the buck riveting part and the buck riveting tool. They're pretty handy. I went ahead and did some back here on the back. Those don't look quite as good, but you'll see the aluminum plate inside because I went through and reinforced the transom support and wanted to buck rivet it in also. That's the transom support I talked about earlier that we put through in the bottom of the boat. I beefed it up with 1/8 inch aluminum and then buck riveted it into place along with using 3M's marine grade adhesive and sealant. So we shouldn't have any problems with that. The last transom support, well, this transom support when it was in it when I got it had already ripped out of the bottom of the boat. And I didn't want to run into that problem in the future, so I just overdid it. Made sure that we had plenty of support from the transom down to the bottom of the boat, in order to give it a larger bearing plate down there. You can notice we redid the transom. The old transom was treated plywood, which basically had turned into mulch at that point in time. So the transom plate was pulled off. The past owner decided it would just to put some steel diamond plate on front of the mulch, hoping it would hold it, but I wanted to do it right. So I went through and did some 1/2-inch marine grade plywood sandwiched in between two 1/8-inch aluminum plates. Those were, the plywood was epoxy coated with a thinned down epoxy to allow for full penetration into the wood. And then all the layers were sandwiched together with 3M 5200. That stuff's great. And then on the top and the bottom, in order to get a little bit more support and strength, I went with some 2x3 by 1/4 inch aluminum angle on the top and on the bottom, just to stiffen the whole thing up, along with a copious amount of stainless steel screws. The screws on this side and on the other side down there, they're the ones that hold on the float pod. And then the float pod was then 5200 into place as well. And then those bolts, you probably can't see it. The bolts were basically, I got an access hole here where I can go ahead and do the bolts. Now those bolt holes aren't going to be permanent. Well, they're going to be permanent, but we've got these nice waterproof hatches so we can still access them, get in there, do whatever needs to be done, seal those down, and pods should be good. I added float pods to the back of the boat because I want this thing to pop up and out of the hole quick. I'm going to be fishing in rivers, and in the past, when I had my 1448, it just seemed like it dragged for a while before it finally planed out. So I went through and put float pods on it, which should scoot the engine forward and push up on the back a little bit more. In this picture, you can see where I took and mocked up the float pods out of cardboard based off the dimensions. The float pods came from Amazon, so I wanted to make sure before I ordered them that they'd fit the motor. We are putting a big motor on this thing just to help try and get it up and off and up and on plane quicker. Thus the jack plate, so we can screw it up and get as skinny as possible. The river we fish tends to have a lot of shallow water in it, and I wanted to try and keep this thing as shallow as possible. So one of the things that I found when I was mocking up the float pods on the boat and putting the motor on it is that we were going to impact the float pods. So I offset those out just 3/4 of an inch on each side, which gave me just enough clearance to get the motor on there with a, I don't know, 1/4 inch or a 1/2 inch to spare on both sides. So she should work out, shouldn't have any impacts with the motor and the float pods. And now it's just a hope and pray. On the inside, I went through before we painted and I put all this aluminum angle in. It's 1/16 inch by 1.5" by 1.5". And then to do the curves, I went through with an angle grinder and a cutoff wheel and just cut small kerfs in them where they needed to be until we got to the flat section. And then once you get onto the flat section, everything straightens right back out again. So that was done on both sides in order to get the radiuses on the boat with the angle iron and not keep it from bowing up. Next thing I need to do before we can start getting into the aluminum structure, the subfloor, all of that stuff, is the angle. Since the boat sets at a slope, that angle needs to be bent down flat and level. So I created a tool with a simple adjustable wrench. I welded on some steel plating on it so that I can adjust it to fit the aluminum, and then I can just use that to bend the aluminum into a level square, level with the boat in order to keep it from being ramped up like it currently is. That's what the tool looks like fully installed on there, and that just allows you to go through and bend those down ever so slightly in order to get them flushed up flat.